Good day, ladies and gentlemen. Today we are speaking about a topic in a grade 10 syllabus of CAPS that is in the topic of Euclidean geometry and its introduction to a midpoint theorem. So I'm going to introduce you to the midpoint theorem so that you can see how it works. Right, so now when we are done with today's session, a couple of things should be accomplished. And then the first one, and those are objectives, is what is a midpoint theorem? And then second question is when to use a midpoint theorem. So you should know what is a midpoint theorem. And then secondly, you should know when to use a midpoint theorem. And then thirdly, you need to know how to use a midpoint theorem. And then lastly, how do you show that you have used a midpoint theorem? Because you can use a midpoint theorem, but how do you then show that you have used a midpoint theorem? Right. Now let's come to the first question. What is a midpoint theorem? Right, let's try to explain it in a right context. Now, let us say we've got a triangle like this one. Here's a triangle. Here's a triangle. Let's call this triangle A, and then B, and then C. Okay. So now the midpoint theorem says that if you have a line, and then if this line is drawn in the midpoint of the sides of the theorem, of two sides of the theorem, which is the midpoint of this side and this side. So this side is equal to this side, and then this side is equal to this side. So if you have a line that you have drawn at the midpoint of the two sides of the theorem, now there is something about that line. Now what is it? Number one, they are saying that that line is parallel to this third line. Right, that is number one. And then number two, they say this line is half of this line. Does that make sense? So if this is 1, this is 2. If this is 2 and this is 3. Sorry, if this is 2, this is 4. That's basically what it means. Okay. Now, if you put it more precisely, it becomes something like this. Okay. And then they say a line joining the midpoints of two sides of a triangle is, number one, parallel to the third side, which is this side. And then number two, it is equal to half of the third side. So this one, if this one is x, then this one is 2x. And just to go a little bit forward, when you have used such a theorem, then you just say midpoint theorem. That is the way in which you show that you have used a midpoint theorem. So we have answered the first question, what is a midpoint theorem? And then we've also answered the question that says, how do you show that you have used a midpoint theorem? But we'll go a little bit deeper into details in those kind of things. So this is a theorem that we'll keep somewhere here. So if you've got something like this, therefore it implies that this is parallel to this and also this. If this is x and this is what? This is 2x. All right. Now, when do you use this kind of a theorem, midpoint theorem? When do you use it? Let us take an example, because, ladies and gentlemen, when you have a theorem, we learn theorems so that at one stage we can be able to use it. It's useless to learn a theorem if that theorem is good for nothing if you can't use it anyway. All right, let's look at this example. Okay, they are saying find the length of BC. What is BC? This is BC. Okay, now this is what we are given. Okay, so we are given this side being equal to this side, and then this side being equal to this side, which are the conditions of what? Of a midpoint theorem. That means that midpoint theorem can work here because the conditions of the midpoint theorem have been met. All right, okay, so now we are here. They are saying, okay, find this side. How can we find it? Okay, because we see that the condition of midpoint theorem have been met. Now let's look at the midpoint theorem itself. What does it say? It says that if you have this condition, they are naming it, then okay, they are saying this part, but okay, we won't want to use this part, the parallel part. But now they say it is equal to the half of the third side. That means this side is equal to the half of this one. All right, so this one is what? Is 3. So what is this one? You can pause this video and try to work it out yourself and then put it back. But when you use this thing, you will actually see that, okay, that BC is equal to 6 centimeter. And then what is the reason for that? It's midpoint theorem. All right, if you did not know midpoint theorem, you wouldn't know how to relate this side with this side, because there is no law that connects this side and this side in a triangle. But wonderfully, now we do have a midpoint theorem. It can be able to do those kind of things for us. So this is one of the cases where midpoint theorem works. Right, okay, let's look for another example. So that we can see. Okay, they are saying find the value of x. Here is x. We do not know what this is, but all we know is what? Is 70 degrees. Okay, so how can we use this 70 degrees to find this one? How can we use it? Okay, now what do we have here? We've got a triangle, all right, and then we've got this side being equal to this side, and then we've got this side being equal to the other side. Now in those, when you see those kind of things, what can you use? You can use what? You can use a midpoint theorem, because the conditions of a midpoint theorem are met. You can only use a theorem if their conditions are met. Now, what does midpoint theorem says? It says that a line joining the midpoints of two sides of a triangle is, number one, is parallel to the third side. Okay, we may use that one. It's parallel to the third side. Okay, so what can we say here? We can say DE is parallel to BC. Now, what is the reason for that? The reason for that is because of a midpoint theorem. Okay. Now, because this is now parallel to this, let's just put this so that we can show that there's been used a different color just to illustrate. Okay, so now we know that this one is parallel to this one, is parallel to this one. Okay, now we've got parallel lines here. Okay, we know that this one is parallel to this one. So because of that, now can you see there is an F shape? Aha, there we go. So these two angles are what? They are equal. Why? Because they are corresponding angles. So x, the one that we are looking for, is equal to what? Is equal to 70 degrees. Why is it equal to 70 degrees? Because it's corresponding angles. Since what? Since DE is parallel to to BC. There we go, ladies and gentlemen. We have got our answer, which is X. Right. So now we do know how we are going to use the midpoint theorem. We use the midpoint theorem to find solutions to questions that are relating to triangles that have the sides being equally and then the other sides being equal. Then in those particular cases, we can use what? The midpoint theorem. There's just one more caution that I would like to bring you guys to, which is very important, is that in a normal case, you won't get a nice case like these cases that I've just illustrated. I've just illustrated those cases because I wanted to introduce you to the idea so that you can be able to play around with it, to understand it in a simple term. But basically or fundamentally, you will get a mixture of questions. But ladies and gentlemen, immediately when you see this being equal to this and this being equal to this, you must know it's what? It's midpoint theorem. So you must know that you can use the implications of a midpoint theorem. All right. So don't be confused when you see things being many. You can still use midpoint theorem. Okay. And then another thing that I want to say, there are two things that are implied by midpoint theorem. Number one, that this line that is joining the midpoints of two sides of a triangle, that it is parallel to the third side. That is one implication. And then the second implication is that it is equal to half of the third side. That is a second implication. Okay. So on your side, you must know that sometimes you may only have to use the first implication. Okay, and then sometimes you just have to use the second implication. It does not necessarily say you must use both of them. You can use one of them at a time. It does not matter. But when it comes to conditions, they must both meet. You must have this side being equal to this side, and you must have this side that must be equal to this side. All right, now that is a midpoint theorem. So now before we close shops, we just want to check if our learning objectives have been met. What do I mean by that? Were we able to satisfy the objectives or to meet the objective that we had in a safe place? So were we successful in this lesson? Okay, what were the objectives? The objectives was to know what is a midpoint theorem. Now we can now state the midpoint theorem and say the midpoint theorem is a theorem. No, before stating it, knowing what it is, it's a theorem that you use when you do what? When you have a triangle and then you've got a line that cuts or that joins the midpoint of the two sides of that triangle. Okay, so that is a midpoint theorem. So it's a theorem that you use in those particular cases. And then what does it say? It says there's a line joining the midpoints of two sides of the triangle is number one parallel to the third side of the triangle, and number two, it is equal to the half of the third side of the triangle. So now we know what the midpoint theorem is. And then when to use the midpoint theorem, we've answered some of those things here when we're explaining this thing. And how to use it, we did show you the examples, and then you saw how to use it. And then lastly, how to show that you've used it? You just open two brackets and then you just say midpoint theorem, and that is how we close everything. Ladies and gentlemen, personalities, thank you very much for tuning through, and have a lovely day, and goodbye.